The kidneys are retroperitoneal on either side of the vertebral column. So they're located against the posterior abdominal wall from the level of T12 through L3. Okay. This is the capsule of the kidney, dense fibrous connective tissue. Just inside the capsule is the cortex, the outer part of the kidney. The deepest part of the kidney is the medulla. Okay. The cortex extends into the medulla as structures called renal columns. This is a great example of a renal column. This is a skinnier one, but there's a renal column in between each of these triangles. Those triangles are more properly referred to as renal pyramids. The base is the wide part, faces the cortex. The apex is the narrow tip, it faces the hilum. The hilum is the medial indented part of the kidney through which the blood vessels and ureter enter and exit. At the very tip of the apex, which is not demonstrated here, is a renal papilla. Okay. The urine drains through the holes in the renal papilla into these little cups, which are called minor calyces. Calyx, singular, calyces, plural. Each renal pyramid is connected to a minor calyx. All right. There's usually a dozen or a dozen and a half of these renal pyramids, so there's a dozen or a dozen and a half of these minor calyces. The minor calyces converge, and they form 2 or 3 major calyces. This looks like there's probably 2 major calyces in this model. The urine then goes into the renal pelvis, which is the wide part, the wide upper part of the ureter, then into the ureter on its way down to the urinary bladder. This is the renal artery, brings oxygen-rich blood into the kidney. It's a large branch off of the abdominal aorta. This is the renal vein. It drains venous blood from the kidney into the inferior vena cava. Okay. Functional unit of the kidney is the nephron. The nephron's got 2 basic parts to it. It's got a corpuscle, renal corpuscle, and a renal tubule. This is some nice detail on the renal corpuscle. The corpuscle is also, the outside of the corpuscle is also called Bowman's capsule or the glomerular capsule. This is a sagittal section through a renal corpuscle. Okay? The interior of it has a parietal layer. This is the parietal layer. The inner wall is the parietal layer, made up of simple squamous epithelium. There's also a visceral layer that covers the glomerulus. Okay? The visceral layer is made up of specialized cells called podocytes. The podocytes have terminal processes called pedoceles. When you work with this, you can see a series of little raised columns. Those little raised columns all over here, those are the pedoceles. The dark lines in between the columns, those are the filtration slits, or the slit pores. Okay? You'll notice that the visceral layer in this model doesn't cover the entire glomerulus. Okay? If you take a close look at the uncovered part of the glomerulus, you can see little pock marks, you can see little holes. Those represent the pores or the fenestrations. Okay? This is the afferent arteriole, this is the efferent arteriole. Notice how large the diameter, or the lumen I should say, of the afferent arteriole is as compared to the efferent arteriole. That sets up resistance here. That increased resistance in the efferent arteriole creates higher blood pressure in the glomerular capillaries. Okay? That forces the fluid and the solvents through the glomerular filtration membrane into Bowman's space. Where my finger is running here, that's Bowman's space, or the capsular space. The fluid produced in the renal corpuscle is filtrate, okay, from the process known as glomerular filtration. When it enters the renal tubule, it's called tubular fluid. This is the very beginning part of the renal tubule. Okay, so let's go over here now, but we'll get oriented. Capsule, all right. From here up, cortex. From here down, medulla. Okay. Let me start here. Okay, this is the renal corpuscle. All right. This is the proximal convoluted tubule. Notice how twisted or coiled it is, which then extends to the descending limb of the loop of Henle. This is the actual loop of Henle. Then the ascending limb of the loop of Henle, the distal convoluted tubule. When the tubular fluid reaches a common collecting duct, this is a common collecting duct, that fluid is then called urine. Okay? Lest I forget, this is the juxtaglomerular apparatus, JG apparatus for short, juxtaglomerular apparatus. Two parts to it, macula densa and JG cells. JG cells short for juxtaglomerular cells. Both of these parts of the JG apparatus secrete or release renin in response to low blood pressure and or low sodium ion concentration. Through the renin-angiotensin-aldosterone mechanism, they bring blood pressure back up to normal. There are two categories, or classes, I should say, of nephrons, which is why I like this. Okay? Again, let's get oriented. Capsule, renal capsule. From here up is cortex. From here down is medulla. Okay? This is a marvelous example here of a cortical nephron. If you look at it, you can see that the great majority of it is in the cortex. 85% of the nephrons are cortical nephrons. The other 15% are made up of what's referred to as juxtamedullary nephrons. Juxta means near, juxtamedullary means near the medulla. You can see how the renal corpuscle is real close to the medulla. You can also see how the loop of Henle extends very, very deep into the medulla. These nephrons, juxtamedullary nephrons, play an extremely important role in helping the kidney to produce concentrated urine. I think I've got everything I want you guys to know here. Okay?